Good morning to one and all present here. So, as a part of this PMR, so this is the fourth lecture where I will talk about the concept called like different kind of concept is there. So, first, the chemical is a very important topic, and in CSN net questions used to come, and that is quite important to if you are planning for your PhD or postdoc, for PhD in India or outside also. So while question answer session, you may be asked this kind of question for chemical kinetics. So in this session, we will take some questions on chemical kinetics, and we will try to get the answer, and we will discuss with time. So this is the first question where you need to calculate the order of the reaction. So for any order of the reactions, first you should know that whether like what is the rate equation, right? So rate equation is written as a minus x whole to the power m, right? Rate proportional to a minus x whole to the power, because rate is nothing but dc dt, means the difference if it is from the reactant side, the difference in the concentration with respect to its time, and rate proportional to a minus x 1 to the power m, and where this is the initial concentration of the pressure, and you need to calculate the final concentration. So just I am reading this question. The rate of decomposition of gases aldehyde initially at a pressure of 363 torr was 1 torr per second. 0.5% had reacted, and 0.5 torr per second when 33% had reacted. So what is the order of the reactions? So here rate is equal to like the concentration which is just now. This X is already the amount of the reactant consumed during the reaction, and A is the initial concentration of the reactant, and M is considered order. This A is the initial concentration, X is the related to reacted already, and M is the order of the reaction. So here the rate is torr per second, right? So rate is here torr per already given 1, and we have the initial pressure this torr. So you need to calculate the final pressure is also the 0.5, and 33% has reacted. So when 5% has reacted, means 95% is unreacted, right? So here from here you can get what is the torr per second, like torr per second. Here you will go to the another rate, right? So when 33% is reactant, 67% are reacted, right? So now you need to compare about the reaction rate, and that is involved in many cases. That is involved with respect to the its order. So here m is the order. So r1 by r2 is what is this 1 torr per second by 0.5 torr per second equal to 0.95 by 0.67 whole to the power m. And this if you just so this is the 2 times of 0.5, so 2 into 1.44 whole to the power m. So this is what, so as you know that root over 2 is 1.414 and root over 3 is 1.732, right? So this is a root 2. This root 2 means 2 to the power half, right? M by 2. So m by 2, right? So m by 2 equal to 1, because here is also the power is 1. So m equal to 2, right? Hope you understand. So m by 2 equal to 1. So m is equal to 2. So the order of the reaction is 2. Okay. So let me know if you have any question. this is a very one of the important question. Now, if in terms of pressure they're giving tone, now if they give the in terms of concentration some mole per kg or something like this, so you need to follow the same procedure, right? So here from here you can say that order is 2, right? Second, this is the first, this is the second order reaction, right? So in the second order reaction, you may sometimes given by some plots like concentration versus time from the time, and from there you need to understand, or you need to calculate what is the value of this, what is the value of the if the concentration was time plot is there.
Now you go to a question where you know about the concept of this order of the reactions. Now you came here, okay. Now if you come here, so they here you need to find the value of A exhibits a rate constant that gram per minute. So this is the like reaction rate constant of 0.5 gram per minute. How many minutes are required to compose 5 gram of A into 2.5 gram? So here you do not concept that you do not know what is the order of the, but from here also you can get the order. So it is a zero order reaction, right? So in the zero order reactions, because you know already rate constant, that concept, you know that what is the like value of getting this rate constant. From this here you can know about, you can get the idea about this minute. So how much gram per minute? So that means this is a zero order reaction, and in the zero reaction obviously you know that A equal to A0 minus KT, right? So basically at the T half, so A will be A0 by 2, right? So if it is A0 by 2 and corresponding, you can get the value of this time, that T half, that means the time required for the half decomposition of the system, and this is a 0.5 gram per minute, and how many minutes is required for the decomposed 5 gram into of this gram, right? 5 gram of A into 2.5. So this is basically the concentration is coming half to the initial concentration. So that means just you need to calculate the value of this half lifetime. If you can calculate the value of half lifetime, then you can obviously you can get the idea about the concept about the about the time required to the, like, to extent of the initial concentration has been consumed, right? So this is a very simple formula, but here they may also give that what will be the state line of your A and T. So with increasing time, you know, if you equal to A0 minus KT, so with increasing time your basically rate constant will be decreased, right? With increasing time, your obviously the reaction is going forward, as a result of which your rate constant will be the concentration is basically decreasing, and equal to A0 minus KT. So there is a plot between concentration versus temperature. So equal to mx plus c, where m basically the slope, which is the k minus k, because with time your amount of this your reactant is basically consumed, as a result that is decreasing. So as a result of which you get the value of negative slope value, which signify that with time your concentration is decreasing. Please let me know if you have a question. So this is also one important. So first one was your second order reactions, and here it is the first order zero order reaction. So here in most of the cases, you know that this rate of the reaction is second order or zero order, but besides you will prove that you can get the other other rate also. So come to here. So for a reaction, so this is also a rate equation where this rate is given as k to the power n into b to the power m, and on doubling the concentration of and half basically you are making the concentration half, the ratio of a new rate to the earlier rate over the reaction will be. This is a very simple questions. So you know that a is going to be 2a, right? A is going to be 2a and v is going to be v by 2. So basically 2 to the power n minus m, right? So this is 2 to the power n minus m. The ratio is okay 2 to the power n, right? So this k to the power n, b to the power n by k, this will be will be will be will be will be rejected by from denominator as a new denominator from these fractions, and 2 to the power n minus m. So n minus m is this value 2 to the power n minus m. So your answer will be D, right? D will be the answer. Here your answer will be 50 minutes, and here your answer will be 2, right? So C 1 C 2b 3d, right? Now come to this question where they asked about the order. They asked about the order of the reactions, and half T half is already given. Half lifetime is already given. From there, they are asking this order of the reactions. This is a very important questions where you can get the value of half order reactions, and yeah. So the half. So this is I am reading the question. So at 450 K, the half life for decomposition of a gaseous compound initially at 65.5 kPa kilopascal was 260 second. When the pressure was 36.6 kilopascal, the half life of was 245 second. Determine the order of the reaction. So T half proportional to pressure, right? So half life changes with concentrations. Half life is depends on concentration, right? And if you look at here, the half life is 360, but with concentration is different. So this will be a zero order. This is a zero order reaction, right? So and you can true false, so right? So P1 by P2 you can get a value of something, and T half by T half, so both the value are more or less equal, right? So the order of the reaction is 0. So this is quite important that this order of the reaction when becomes 0, so that time the concentration of reactant is decreasing with time, so A equal to A0 minus KT. So this is the value of the of the reactions. And in most of the cases this value depends on the other things also, because T half depends on the concentration also, and there is a formula where you can get the value of your order of the reaction by changing the reaction rate at different reaction rate, keeping the different reaction rate constant, right? Please let me know if you have any questions. So initially you need to find the value of this order of the reaction, that is the 2, and in this case your half life is 50 minute, and here the value of this what I will say this um, ratio of old and new your reaction, so it is 2 to the power n minus m, and in this case 4 is like equal to 0 minus kt. As you know, with concentration the value is the t is decreasing, so as a result of which you will get the concept called zero order reactions, and from there you can calculate the value rate of the reactions. So this is a question where you need to follow this value equal to v equal to v max into s by 1 plus k. This is very important, and this is v equal to v0 v0 equal to v max into s by km plus s, and just you make it reciprocal, and if you make the reciprocal, so 1 by v0 equal to km by v max into s plus 1 by v max, so y equal to mx plus c. So here this is equal to 1 by v0 equal to km by vmax into s plus 1 by vmax, so y equal to mx plus c. In this equation you can put all the values, and you can get the velocity of the rate of your reactions. In the next question we'll talk about the value of this question. For a consecutive reaction in which first step is reversible and the second step is irreversible, so for that q1 is given to you. So rate constant for the formation of nitrogen you need to find out. So k1 is already given, so this is a little bit long question, like a long type question, so we'll do it very with time, like very slowly, to so that we can understand properly it, so that we can understand it properly. So here k1 is given to you, and corresponding k minus 1 is also given to you, and k2 is also given to you, right? So here k1 k2 k, the rate of the formation of n, how k2 into m, right? K2 into m, this m can be formed two ways. So k1 into l minus k minus 1 m minus k2 m, right? So this is equal to 0. So this is the steady state approximation, where m concentration, you can say that with time this concentration, change in concentration is more or less 0, right? So it is considered as steady state approximations. So m is called steady state approximation. So at the value of this m, where m is the intermediate species, this is the steady state approximation, and here in steady state approximation we will have the value k m equal to k1 by k minus 1 plus k2. So in this case, this k1 by k minus 1 plus k2, this is a very good equations where you can this is one equation 1, this is equation 2. So now you can put the value of m here, so it is coming k1 k2 into k1 by k minus 1 plus k2 into L. So k observation k2 into k2 by k minus 1 plus k2. Putting these values of these rate constants, k observation equal to 10 second inverse into 10 to the power 6 mole liter mole inverse second inverse 10 to the minus 4 second inverse plus 10 second inverse. So if you do all the calculations, so your observation is coming 9.9 into 10 to the power 5, right? 9.99 into 10 to the power 5. So your answer will be C. C seems to be your answer. D. Now in all of the questions, you know that in all of the questions, in your all of the questions, the value is coming around 9.9 into 10 to the power 5, and this is the for linear Weber Park equation. So where you can get the volume of P0, that means the rate of the reaction enzyme reactions, and here you can get the just do it reciprocal of the system and you can get equal values. And here m is the steady state approximation. If you do so, you can get the value of your now come to another questions where you need to consider four 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 what I will say, four reactions where A2 is going to be A2 is basically homolytically cleavaged, A dot plus A dot, and A dot is B dot plus C, and A dot plus B dot, A dot plus B dot P. So K1, K2, K3, K4, these are the rate constant values. So now they are saying to make these state approximations on A dot, right? So A2 appears in the initial step only, so this A2 equal to minus K1 into A2, right? Consequently, the rate of the consumption A2 is first order in A2, and the reaction is dependent of intermediate concentration. A2 is only dependent on concentration of A. Right. K1 into A2. So minus K1 into A2. So this is the, so answer will be B. So in most of the questions you can do this value, that how is the value of your rate of your order of the reactions, and what is the relation between this k max velocity as well as is the value of this substrate concentration for enzymatic reactions, and this is the or determine the order of the reaction. So if by choosing the order of the reaction you can get the value of order. And this was the another, you need to calculate the ratio of this rate, that is the ratio of new rate to the earlier rate of the reactions will be as like this. So these are the very important and useful questions which can be asked in CSI and NERCAT. And here you need to calculate the like T half, basically the T half, because your concentration or the amount of overflow of the substance has been increased to 2. And this is the order of the reactions where you can do this. Is 2.